In today's lesson, we need to take care of some vocabulary words to start. So the first vocabulary word is term. And a term is a number, like 7 or 12 or 15 or -8. Or a term could be the product of a number and a variable. So a number next to a variable, a number next to a letter, like 3M, 3 next to M. And I wrote a hint down, and I said a hint could be that a term would be a number, or it could be a letter by itself, or it could be a number next to a letter. So, if you need some examples, I've got 4 and -8, S, -W, 3R, -7M, 2XY. Because remember, a term is one piece all by itself. So 4, it's one piece of an expression. -8, S. If you remember, there's an invisible 1 in front of the S. Excuse me, it's in front of the S. Okay? So each piece there is a term. If I wrote this on the board, 3M plus X plus 8, the 3M is a term, the letter X is a term, and the 8 is a term. Alright, let's find some more terms here. So our next vocabulary word is the word constant. Now if you think of constant outside of math, constant means it's always the same. Okay? So a constant in math is a term that has no variable, which means it's a plain old number, like in my examples, 4, -8, 3, -7, and 2. Those are all constants because constant means it's always the same. The number 4 always means 4 of something. Whether you're talking about 4 dogs or 4 chickens or 4 pieces of pizza, a constant is just a plain number because it can never change. A number is always the number. It always means the same. A variable, like we've learned in the past, like X, in some cases is X would stand for 3 or X would stand for -12. So that's why a constant is just a number. It always is the same thing. Another vocabulary word we have, like terms. Like terms have to have identical variables. So the hint is that they have the exact same letter in the term. 4x, -8x, and x in our example there. And remember, x could mean the same as 1x. Those are all like terms because they have the same letter. 4 x-rays, -8 x-rays, 1 x-ray, whatever x is, whatever x stands for, those 3 terms all have x, so they're considered like terms. Now in the next example that I'm underlining here in red, 3, -21, and 45, those are also considered like terms. And the reason they're considered like terms is that they're all constants. And you might say, well, they don't have the same letter. Well, they don't have a letter at all, so that's what makes them like terms. They're all constants. So since they don't have a letter, they're a constant, they are like terms. Our last vocabulary word is coefficient. And a coefficient is the number that is next to the letter. Okay, it's a number that multiplies a variable. So in this example, 3m, okay, the term 3m, 3 is considered the coefficient because it's the number that multiplies by the variable. Let's see another one, -4x. -4 is the coefficient because it multiplies the variable. It's the number next to the letter. It's the number that gets multiplied by the variable. So make sure you've got all 4 of those vocabulary words and definitions written down. Remember, we had term, constant, like terms, and coefficient. So let's get those written down, and then we will do a little work with them. In this expression you see on the board, it's probably not on your paper, the expression says 2a plus 7a plus 5b plus 8. If you look at it carefully, you should be able to figure out how many terms are in that expression. So real quick, turn to your neighbor and show them on your hand or hands how many terms you see. Now, if you look up here, 2a is a term, 7a is a term, 5b is a term, and 8 is a term. So there are 4 terms in that expression. Now, when you look at those 4 terms, do any of those look like constants? And if you're saying, well, what the heck's a constant? Look back in your notes. Remember what a constant is. Turn and tell your neighbor if there's a constant. And if there is a constant, tell them what that constant is or how many constants there are and what they are. Take a second and do that. All right, hopefully you noticed 8, the term 8, is a number all alone, so it's a constant. There's no variable attached to it. So 8 is considered a constant. Now take a look at that expression and see if there are any like terms. If there are like terms, again, tell your neighbor what the like terms are. And if you don't remember what like terms are, look in your notes again. Take a couple seconds, turn and tell your neighbor what the like terms are if there are any. Okay, take a look up here. 2a and 7a are considered like terms because they both have the same variable. They both have the variable a. And if you're somebody who needs to think of something visual, think there's 2 apples plus 7 apples. Well, the apples are like terms. Then it says plus 5b, maybe 5 bananas. Well, those aren't like terms. You don't put the apples and the bananas together. So 2a and 7a are considered like terms. Last thing I'd like you to look for in this expression. Look and see if there are any coefficients. So decide if there are any coefficients. And then I'd like you to turn and tell your neighbor, if you see any coefficients, what they are. So go ahead and take a few seconds and do that. All right, taking a look back up here. Coefficients. Remember, a coefficient, if you look at your definition, it's the number that multiplies the variable. It's the number attached to the letter. So, in this case, we've got coefficients. We've got 2 as a coefficient, 7 as a coefficient, and 5 as a coefficient. So those 3 numbers are all coefficients because they are attached to a letter. They multiply the letter. Okay? So again, terms are each piece in the expression. Constants are numbers that are not attached to a variable. Like terms are terms that have the same variable or the same letter. Coefficients are the numbers attached to the letter. So hopefully we've got that figured out. We're going to put it to work a little more now. All right. If this expression is not in your notes, please get it in your notes. It says 3m subtract 2n plus n minus 4. And notice above it on the board, I wrote, write this in big colorful letters. So make sure you write that sentence. It says, before you work with an expression, change all subtraction into addition. So you got to think back to chapter 1 and think about how we changed subtraction into addition. And if you need to, you might have to get out your chapter 1 notes. Think about what we did. How do we change subtraction into addition? If you have an idea, get ready to share it with us. All right, so changing subtraction into addition. When I look through this expression, I see 3m minus 2n. And if I go back to chapter 1, I remember this is what we called stuck like glue. We're going to glue the negative sign onto the 2n, and we're going to sneak a plus sign in between. So now it says 3m plus negative 2n plus n minus 4. I see another subtraction sign. And again, we can use the old what we called stuck like glue strategy. We're going to glue the minus onto the 4, sneak a plus sign in there. So now our expression is rewritten. It says 3m plus negative 2n plus n plus negative 4. So if I look at what we started with this, 3m minus 2n plus n minus 4, and it changes to 3m plus negative 2n plus n plus negative 4. And for those of you who like to have numbers, you could sneak the invisible 1 in next to the n. So the coefficient on n there is a 1. Okay? And some kids say, well, why do we have to do that? Well, as we move on and we solve with our expressions, which we'll be doing in the next couple days, we need to be able to rearrange the terms in the expression. We're not going to worry about that today, but that is why we have to change subtraction into addition. So we will be able to rearrange things. And if you remember back to chapter 1, the only time we can rearrange is if it's all addition or all multiplication, but we're not worried about that at this point. Okay? Now, if I look at the new expression that we have, 3m plus negative 2n plus 1n plus negative 4, how many terms are there? Quick, show your neighbor on your hand or hands. You should be holding up a 4. There are 4 terms. 3m is a term, negative 2n is a term, 1n is a term, negative 4 is another term. Constants. Turn and tell your neighbor if you see any constants, and if you do, what are they? The only constant I see in there is negative 4. It's a constant because it's a number all alone, not attached to a variable. Turn and tell your neighbor if there are any like terms in there, and if they are, what are the like terms? The like terms I see are negative 2n and positive 1n. Those are called like terms because they both have n's. Coefficients. Turn and tell your neighbor if there are any coefficients, and what are they? The coefficients I see are the 3 because it's attached to an m, negative 2 because it's attached to an n. Remember, in the first expression, the way it was written, you might say, oh, that's just a 2 attached to an n. But before we can work with the expressions, we have to turn them into addition. So that's why we say the coefficient is negative 2 on that n. And the only other coefficient I see is a 1, which is attached to the n. And again, you might say, but there wasn't a 1 there, you put it there. But if we remember back to chapter 1, the invisible 1 is there, so we do need to write it down as a coefficient. Or we need to understand that it is a coefficient. So let's put all that we've just done to work now. I'll do the first one with you, and then you're going to do the next 2 on your own, and then we'll check together. So what we're going to do is look at letter A that says 6 plus 2s plus 4s. Just looking at that expression, what we need to look for first, right here, are coefficients. So looking up here, any coefficients that you see. Whatever coefficients you see, let's write them down in this box. Remember, a coefficient is a number attached to a letter. I see a 2 attached to an s, so all I write is the 2. We don't write 2s because all they're asking for is the coefficient. What's attached? Coefficient means the number attached to the letter. The other coefficient I see is a 4 because it's attached to s. Those are the only coefficients I see there. Like terms, remember, have to have the exact same letter. I see a 2s and a 4s. They both have s, so 2s and 4s are like terms. So when we write there, we need to put the number and the letter. The last thing they're asking for is constants. Remember, a constant is a number all alone. The only number I see all alone up here is a 6, so I'm going to write a 6 there. That's my constant. Your job is to do the same thing with part B and fill in these boxes for part B, and then try part C and fill in these boxes for part C. And we will check together in a minute. All right, hopefully you've taken time to try all these. Let's go through the answers quickly. Coefficients are numbers attached to letters. I see a negative 4 attached to x. That's the only coefficient I see. Like terms have to have the same letter. There's nothing else with an x, so there are none. Constants are numbers all alone. I don't see any numbers all alone in this expression, so there are none in this case. In the last one, remember, before we start, we have to change subtraction into addition. Hopefully you remember to do that. And if you want to put in the invisible 1. So here we go. Coefficients. I see a 9 attached to an m. I see a 2 attached to an r, a negative 2 attached to an m, and an invisible 1. So there are actually 4 coefficients. Like terms, 2r and 1r. There's one more set, and that's 9m with negative 2m. And last, constants, there are none.